All right, so we're going to do an activity here with the marriage ages, and it's just a nice comprehensive activity. So you probably remember this chart where, you know what, I'm going to open up the chat too. So I mean, the chat's open anyways, but if anybody has any questions as we're going through this, or you want to, get my attention and don't feel like talking in the microphone, just pop it in the chat there and I'll probably see it. So this is a table of ages for when husbands and wives got married, their ages when they got married. So this particular first one here, the husband got married, he was 25 and the wife married him at 22. The difference in their ages is 3. So this difference is husband minus wife. Okay. And so like over here is just a continuation of the table. So this couple here, the husband was 62, the wife was 60, the difference is 2. This one here, the husband was 26, the wife was 27, so the difference is -1, indicating that the wife was older. So so we're going to use that data, and we're going to answer some of these problems here. So let's get the ink off of there. Okay, good. So let's use some technology to calculate the mean and median age for each group, husbands and wives, and then which spouse tends to be older and by how many years on average. So I'm going to make a little table here. I have husbands and wives, and I'm going to have the mean and the median, and then and then I'm going to have the difference. Everybody following what I'm doing here? I'm going to answer this problem like that. So I'll do the first part. So, whoa, that's really weird. Why does my calculator look like that? That's better. Okay. You should have this data in your calculator. I'm going to go stat edit, and you can see I already put in the data here for husbands in L1 and wives in L2. So I'm going to go stat calc, one variable stats, and I want to do husbands first. So I'm going to do second 1 for list 1. I'm going to hit enter. And I find out that the mean age, the average age that husbands got married was, let's say, 35.7. So 35.7. That's the mean age that husbands got married at. And if I want to find the median, I have to scroll down here, and it says the median was 30.5. That's a pretty big difference actually between mean and median. 30.5. Everybody okay with that? Yes? All right, then what I want you to do is do it for wives. I want you to find the mean and the median for the wives. So let's ask, Isa, did you get an answer? You have a calculator.
A calculator, I'm sorry.
Shame on you. Where's your calculator holster? You need to be carrying it. What?
I was just showing you I had it.
Oh, so what's the problem then? You don't know how to do it, or you don't have the data, or what?
No, I was still trying to input it. I was trying to put it in, yeah.
Oh, okay. All right. All right. Brooklyn, do you have an answer?
I'm trying to figure out how to get that data. I just end up getting the husband one. I don't know what I'm doing wrong.
You don't. Okay. All right. So, all right. So as we go along in the course, I really want you guys to kind of get the data loaded on your calculators, like before we begin the topic, and that'll just save us a lot of time and enable everybody to kind of keep up. So,
Mr. Jenkins, I have both of them. I just don't remember how to get the wife one.
Oh, okay. Well, then here, let's is it did you put it in your list, or you just want to use the raw data?
Yeah, I have it in list 2.
Okay, so if you want to find out how to calculate it, you press stat and then scroll over to calc. Then one variable stat. Are you with me, Brooklyn?
Yeah.
Okay, and then go second 2, because right above 2 you see it says L2. And then press enter, and there's your data.
Okay.
That work for you?
Yeah.
Okay. All right. So X bar for wives, I have 33.8, and median for wives, I have 29.0. So I'm going to ask a question here, and this is an interesting question. I'll take a volunteer for this one. I think that the mean and the median for both husbands and wives are pretty far apart. But why aren't they very close together? Why aren't the mean? They're both center. Why aren't they very close together? Volunteer?
Maybe the data is skewed, so the mean is distorted.
Well, let's take a look. I'm going to go second, stat plot. My plot 1, I'm going to look at that. And let's take a look at, instead of doing L3, let's take a look at L1. So second 1, enter, zoom 9. Sure enough, data is skewed. So data is skewed, it's distorting the mean. Does that make sense to everybody here? Yes? Yeah. So if I was to be reporting on this, I would just want to report the median. I wouldn't bother reporting the mean. And it makes sense that the data is skewed, because I think, you have a handful of people over here who get married at older ages, but most people are getting married here at, what I would consider younger ages. You might consider them older ages, but I'm considering them younger ages. Right. So I have let's figure out the difference. So I have 35.7 minus 33.8. So the difference in mean between husbands and wives is 1.9. And the difference in median is 1.5. Well, now that's very interesting. That the difference in that the mean and the median of the difference are actually relatively close together. So we'll come back to that in a minute. All right. So let's calculate the IQR and the standard deviation of the ages for each group. So I'm going to go stat, calc, one variable stats. My husband's is in list 1, so second 1. All right, enter. So standard deviation is the SX. So that's 14.5. Let's go 14.6. 14.6. And to find the IQR, I have to subtract Q3 from Q1. So I have 44.5 minus 25. My IQR, 19.5. Okay, you guys do it for the wives. Find the standard deviation for the wives and the IQR for the wives.
Mr. Jenkins, I sent you a chat.
Oh, I see. Okay. Okay, there actually is something that you can use for that. Remind me and I'll show you right after the class. And you know what, I'll send it out. I'll just let everybody know this. I'll send out an email on it.
Okay, because a lot of people were saying the same thing, that they wanted to have it so that they could just automatically write their answers that we're doing in class and like on their own packet. I think it'd be like really helpful.
Yeah, it's actually right there in the lessons folder. All the slides are right there in the lessons folder, but I'll point it out. So that's good. Okay. So Alexi, are you here, Alexi?
Yes.
You are. Oh, there you are. Okay, good. All right. So did you get data for the wives, standard deviation for the wives?
Not yet. I'm still working on it.
Okay. Abby, did you get it? Oh, Abby, you're here. Yeah. Okay. Are you typing me something, Abby? Okay. Okay. Ah, okay. Did you get the numbers and you want to type them in the chat? You give me a Y or an N or give me the numbers. Okay, so you got the standard deviation at 13.5 and the IQR. You don't have that yet. Okay, that's fine. Hang on. So Brooklyn, did you get an IQR?
I'm looking for it right now. Is it what like symbol is it next to?
So IQR is Q3 minus Q1. The calculator is not going to give you IQR
Okay.
as a separate line. You have to take Q3 and subtract Q1.
Then it's 25.5.
Is that right? 25.5? I'm asking everybody here. Anybody else get an answer?
I got 17.5.
You got 17.5. Let's take a look. Stat, calc, one variable stat, second, two, because I'm using list two. So the standard deviation is good, 13.5. The IQR, I'm going to take 41.5 minus 24. So 40.
Mr. Jenkins, I accidentally subtracted the minimum, so it is 17.
Ah, yes, that would make a difference, wouldn't it? Okay, so 17.5. Good. That's good. Okay. Is everybody okay on that? Raina, you had a question. What was your question?
For the standard deviation, since it was 13.56, I rounded it up to 13.6.
Yeah, that would be fine. So one of the things that we're going to learn about a little bit later on is, well, you know, rounding. I don't know about you, but I kind of find rounding to be irritating, especially when there's zeros, you know, and one's a 9, and then it goes up to a 1, and then you have to bump the other one up, and I can never remember. So one of the things that we do in stats is we do this thing called truncate. So if I had like 13.56, but I only wanted to use 1 decimal, instead of rounding, we just truncate, which is a great word because it sounds like just what you're doing. You know, you're just cut it off, you know, just get rid of it. And that's acceptable to do. Okay. But 13.5, 13.6, in this class, it's not going to make that much of a difference. We're not engineers. We're not sending somebody to the moon where 0.5 or 0.6 might like miss the target, you know, and send them off into deep space. Right? We good with that? Yeah. So truncate, as you can see, is very easy. So, and I kind of like truncating. Okay. Part C. Comment on how the age distributions compare, citing numerical summaries for support. Well, we have our numerical summaries here, but when it says, you know, like comment on the distribution, shape, center, spread, all right? You gotta make your histogram. Shape, center, spread. So if I'm doing husbands, I'm gonna go second, stat plot. And I already made the histogram for husbands, but I'll just show you again. So I hit enter and I make sure it's on. And then the type is the histogram, and I can see that that one's on. And my husband's is in list 1. So I enter that. And then I go zoom, and this thing pops up, and I go zoom 9, and there's my histogram. Now, I would not leave the histogram like this. I actually probably could for this particular problem because it is very clearly a skewed right histogram. Does everybody agree with that? Okay. Emma, don't let me miss that question, okay? All right. It's definitely a skewed right histogram, but if I was really kind of be a little bit more precise here, I would go to my window and I would see that my bin size here is 8.666, so 8 2/3. And I don't know about you, but I don't think in 8 2/3. I think in 1s, 2s, 5s, 10s, nice, comfortable numbers. So I would come down here and I would change that to 10. And then I know that my minimum and my maximum have to be evenly divisible by 10. So you might come up here to the minimum and think, oh, well, it's 19. I can make it 20, but then you're cutting out that 19 data point. So it has to be divisible by 10, but lower. So I have to make my min 10. And then I come to my max and it's 79. Well, I can go, it has to be higher so I don't cut off any data points. So I'm going to make it 80. And now if I look at my graph, oh yeah, I have a nice graph there. And then actually this graph points out a couple of interesting things. So it's definitely skewed right. So I'd write skewed right. I'd write the center. Well, I would say the center is 30.5. I would only use the median because it is a skewed distribution. 30.5. And my spread, again, since it's a skewed distribution, I'm using the IQR. IQR of 19.5.
Mr. Jenkins,
Yes.
something's wrong with my my plots, I think. Like my thing looks like that.
Oh, well, yes, I would agree that something's wrong with that. Okay, so in order to get to that, did you go zoom 9 or did you just press graph?
I think I just pressed excuse me, graph.
Yeah, so what that does is that uses the window from the last graph that you made. And that's not a good window. So always start with Zoom 9. Do Zoom 9.
I'm having like a cough attack right now.
That's okay. I can see. Are you okay? Yeah.
Yeah. Okay. Now it looks like that.
Okay. What did you use for your bin size?
Um,
You did Zoom 9 on your list 1 and it looks like that?
yeah.
Is your list 1 the husband's data?
Yeah.
All right, we got to take a look here. I'm sorry. Stat, edit. So your data looks like this, 25, 25, 51, 25?
Yeah.
It does?
Mm-hmm.
Okay, then go stat, second stat plot.
Second stop plot.
Yeah, I want you to,
Oh, okay. Okay.
I want to see what you have in there for your plot 1.
I have.
Yeah, so what you're doing there, Emma, is your frequency should be 1. It shouldn't be L1.
Okay. Do you know how I change that?
Yeah, just scroll down to it. You know, with the button here.
Okay. So do I just
take that down to frequency?
So do I click 1 to get to that?
Is the A flashing?
The A?
Is there on the frequency? Is there? You see on mine I have this little letter A that's flashing.
Yeah. How do I get to that page though? Do I just like with that? Do I hit 1 for?
No. Yeah. Hit 1. Yeah. Hit 1.
Okay. And then.
Then scroll down to where it says frequency.
Okay. And then I change that to 1.
Yes. And is it flashing A?
No.
Okay. Then just press the number 1 and it should work.
Okay.
Does it work?
Do I graph it now?
Yeah. Now go Zoom 9.
Okay. Zoom. There's a Zoom. Okay. I got that.
Very good. Okay. So it doesn't look like mine because you need to go ahead and change your bin sizes. Okay. So I'm going to let you do that. Okay. But so one thing that's interesting about this histogram here is that, and this is notable, I think, if I press trace, I can see this is the bin that's people married between 10 and 20, men, husbands. That's only one of them. Between 20 and 30, I have 10. Between 30 and 40, I have 7. But I have a gap right here between 40 and 50. And I would say that is notable. That actually kind of surprises me that there is a gap of people between 40 and 50. So I would actually write that in. I would say there's a gap between 40 to 50. I think that is notable. So I have shape, center, spread, unusual features. I would not call these guys out here outliers. They're kind of connected enough to the graph. I wouldn't really bother calling them outliers. Are we okay? I'm making sense. Everybody's with me here. Okay, right? Then shape, center, and spread for the wives. You do it. let's do this. Let's do this. How we doing? We doing okay? Finish? Anybody finish? Not yet? Couple? Okay. I'll give you another minute or two. All right, let's ask Sylvia, how'd you do on it?
Sorry, I just came back from the restroom. I'm a little confused.
Okay, okay. Hang in there. We'll go over it. You'll get it. Is it Isabella? She's doing poll work today. That's right. Okay. So Juliana, how you feel about it?
I do not feel good about it.
No? You want to try it or no?
Yeah, I didn't write down if it was like skewed or not because I changed the bin size and I think I messed it up entirely.
Oh, really?
Yes.
Oh, okay. Well, when you did Zoom 9, was it skewed?
Yes, I believe. I don't even know. I have it like I have it all messed up right now.
All right, all right, all right. Well, show it to me. Show me what you. Well, if you think it's all messed up, we're not going to do it.
Yeah, it's
Hang
like
on, hang on, hang on. It's okay. I'm glad we're practicing this. So let's see here. Alexis, what do you got?
I didn't get a chance to change the bin size because I was trying to, but I just I didn't want to mess it up. So I like left it as it was.
Okay, so we'll do that together. So what did you get for shape center spread?
So shape, I had like skew to the right.
So I think it is skewed to the right. Uh-huh.
And then the center is 29.
The center is 29. You use the medium. That's good.
And then spread, I said it was 17.5.
17.5. And well, so you didn't finish your graph, so we don't know whether there's any unusual features or anything here, right?
Yeah, no.
Okay, so let's take a look and do this one together. So I'm going to go second stat plot. And you know, I have plot 1 kind of already set up for a histogram. The only thing I really need to change here is instead of doing L1, I'm going to do L2. So I go second 2 and hit enter. And then when I go zoom 9, I get zoom 9. I get something that looks like that. Definitely skewed right. Definitely skewed right. But I do want to adjust the bin sizes. I do notice there's a gap here. But if I kind of push the trace button and I scroll over to that gap, I find there's a gap between 63.5 and 73. And I'm sorry, but that just is not numbers that make any, I hate those numbers. Oh, so you got that. That's good. Okay, so Juliana, you're right on there. Okay, right. But let's change the bin size. Let's go and make sure that this works well. So I'm going to press window. And I see it gave me a bin size of 9.5. Again, I don't think in 9.5s, but that's close enough to 10. So I'm going to make it 10. And then my X minimum, well, again, that has to be lower than that, but it has to be evenly divisible by 10. So I'm going to go 10 right there. And my X maximum, I'm going to go up to the next number that's evenly divisible by 10. I'm going to go to 90. And then I'm going to go graph. And I get a nice graph here, but this column right here is off the top. I can't see it. So I need to kind of go back to my window, and I need to change my Y scale, my Y maximum. I need to go up from 9. I'll take it to 12. And then I hit graph, and now I can see the whole thing. Can everybody see it okay? Yeah, okay, so again, clearly skewed right. The center, I'm going to use my median. The spread, I'm going to use my IQR. And again, I want to emphasize, it's really important. You have to look at the histogram to know which center or spread to use. If you don't, you might use the wrong one, and then the problem is wrong. You're not giving the people the right information. And I don't really see anything particularly unusual about this. I don't see any gaps or anything like that. So I would just go shape, center, spread, and that's what, and I've done it. I'm done. Are we okay with that? Everybody fine? Okay, well, all right. I missed a problem here in part B. It says, does one group of spouses have more variability in their ages than the other group? And so if this is a measure of variability, well, for standard deviation, husbands have a higher standard deviation than wives, but I'm not looking at standard deviation because I only use that when I have a unimodal and symmetric distribution. I don't use that if it's skewed. But IQR similarly, the husbands are 19.5, the wives are 17.5. The husband's data is more spread out than the wife's data. In fact, let me just give you a sneak preview here, okay? I'm going to go second stat plot, and in plot 1, I'm going to make it a box plot, which again, we're going to talk about this later. This is a box plot right there, and I'm going to make that one L1. I want to make that the husbands, and then I'm going to go second stat plot, and I'm going to go to plot. Wait a minute, plot 1 didn't come out as a, what's going on here? No, this way. Plot 1, I didn't make it a box plot. I have to make it a box plot. Enter, that did it, okay. Now I'm gonna go to second stat plot, and I'm gonna go to the next one. I'm gonna turn it on. Then I'm gonna make that one a box plot. And I'm going to make that one L2, second 2. And I'm going to go zoom 9. And I have 2 box plots there. So the top one is husbands, the bottom one is wives, and the spread is indicated by the size of the box. So I can see really clearly that there is more variability here with the husbands than there is with the wives. And we'll talk about that on Friday when we talk about box plots. But I just thought I would show you that we can see it graphically really very easily. Okay, continuing on. Notice that the table also reports the differences in ages, subtracting the wife's age from the husband's age for each couple. Calculate the mean and median of these age differences. Well, okay. I'm going to go, I have that data in my list 3. Do you remember how I did that in list 3 by subtracting list 1 and list 2? Yes? No. Okay, well, I'll do it again then. So I'm going to clear this list 3. I'm going to hit I have my cursor up here on L3. I'm going to hit enter. It takes me down to the bottom where all the data is in a line, and I'm going to press clear, and I'll press enter. You can see all the data in L3 went away. So I'm going to go back up to L3. I'm going to press enter, and I want L3 to equal second 1, L1 minus second 2. So I want it to be husband minus wife. And I put it in there. And there I have the differences. It's all laid out there for me right in the table. Everybody pushing buttons with me? We're okay? Doing all right? All right. So it says calculate the mean and median of these age differences. Okay. Stat, calc, one variable stat. That data is in L3. So the mean the X bar is 1.875, and the median, scroll down here, is 1. It says calculate the IQR and the standard deviation of these differences. Well, I'm going to do that right here while I'm at it. If Q3 is 3 and Q1 is negative 0.5, the IQR is equal to 3 minus negative 0.5. That is positive 3.5. And the standard deviation, well, is 4.8. SD equals 4.8. We'll go to this 4.8. So 3.5 to 4.8. Everybody see what I did there? Okay, now I want to point something out. With our, I want to ignore this last question here. We don't really need to talk about it. But what I do want to talk about is this. For the husbands, the difference between the median and the mean was really pretty large. It was like more than 5. For the wives, it was in the high 4s, but the difference was only 0.4. So the centers were very close. For the standard deviations, no, I don't care about the standard deviations. I'm looking at the differences here. The differences were pretty close between the centers. 1 to 1.8. So when the mean and the median are close, it usually means that I have a oh, that is a beautiful curve. Man, I don't think I've ever made one that nice. That's really good. I had this student. Oh, damn it. Why can't I remember her name? 2012, my very first stats class. Oh, I can just see her. I can see her like right in front of me. And it's really irritating me because we actually had a Facebook message within the last year or so. And I can't remember her name. Marissa, no, was it Marissa? Oh, well, Marissa Gonzalez, I'll have to look. But she made perfect curves like all the time. But the mean and the median will be very close when I have a unimodal and symmetric distribution. So let's look at the histogram here. Second, stat plot. Let's turn them all off so I don't get messed up. Second, stat plot. Let's do 1 and turn it on. Let's make a histogram. And let's do it for L3. Second, 3. Zoom 9. I mean, I wouldn't say it's the best unimodal and symmetric, but I would say that that's kind of like, that's more symmetric than not. I don't think it's terribly skewed. Are we accepting that? Yes, we'll accept that. All right, great. All right. So last part of this problem is F. I want to determine how many and what proportion of the age differences fall within one standard deviation of the mean. Okay, now I'm looking at the differences. I'm looking at L3 right here. So for L3, it told me that the mean was 1.875 and the standard deviation was 4.8. So if I was to make a little diagram here, that one's pretty good too, frankly. I would have my mean right here in the middle, 1.875, and one standard deviation positive is 1.875 plus my standard deviation of 4.8. So 6.675. And one standard deviation the other way would be 1.875 minus 6.675. And I get negative 4.8. Now remember, we're dealing with the differences. So it's okay to have negative numbers. A negative number just means that the wife was older than the husband instead of the husband being older than the wife. Am I clear on that? Yes? I'm seeing mostly yeses. Okay, great. All right. So let's go back and look at our data. Our data is right here. Let's make a 2-page display. I want to look at the differences, and I want to find all of the differences that are between, come on, Glenn, find your graph again. Between negative 4.8 and 6.675. So I want my differences less than or equal to 6.675. And since they're integers, that basically means less than 6, but greater than negative 4.8. Well, that means greater than negative 4. So everything between negative 4 and positive 6, I need to count them. I want to pause right there and make sure everybody understands why I use negative 4 here and negative 6 here. I had to use integers because all my data here is in integers, and I can't have, if it's negative 5, it's over on this side. It's not between these two. If it's 7, it's on this side. It's not between those two. So I'm looking for things between negative 4 and 6. So I'm going to count them. I got that one there. Now that one doesn't count. That's too far away. That one there. That one there. 5. That counts. It's less than 6. 3. This one's too big. That one's too big. That one's okay. That one's too big. 0 is right on the money. Negative 5. Nope. Negative 5 is outside of my interval there. That's okay. That's okay. That's okay. That's okay. That's okay. Again, too far off. That's okay. That's okay. That's okay. Too big. That's okay. That's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 of them out of 24. Well, 17 divided by 24 is equal to 0.7, we'll call it 7.1. I would say 0.71 is pretty close to 0.68. Would you agree or disagree? People agree? So 0.71, not too far from 0.68, 3/100ths away. And what does our empirical rule tell us? Our empirical rule tells us that between -1 and +1 standard deviations, there should be about 68% of the data. when I have something that is unimodal and symmetric. Oh, astounding. That's tremendous. Okay. Did you get it? That was a lot of stuff. I did a lot of talking, but at least you guys were pushing buttons as I was going along. Yeah, are we okay with that? I did make a recording of it. I am going to ask you, well, I mean, we only have 5 minutes left, so I'm not going to ask you to do it right now, but among the problems that I suggested that you do is this one here that I will show you right now. Desktop stats. Where are you? Z-score problem. Is this one here? It's 9/11. It's about baby weights. This is a good problem. It's kind of a basic Z-score kind of a problem, but you know, you need some practice on it. Now I'm going to make a video on this problem and send it out too, so that everybody has it. All right, are we hanging in there? All right, the last thing I'm going to mention here is, and I will send this out in an email, but if you look in the see stats, if you look in the lessons folder, and I'm going here to unit 2, which is what we're in right now, and here's topic 9. You'll see right down here at the bottom, it says book and then book PDF. This book PDF is basically straight up a copy of the book, which is really what I made the slides out of. So you can kind of follow. It's not as good as actually having the book, but you can kind of follow along here. But this one right here that says topic 9 objectives and practice. No. Topic 9 measures of spread PDF. If you open that up, those are the slides. So this is every single slide that we're going to go through. So you can use that if you want to take notes on that. Isa, does that satisfy you? That's good. So it's right there for you. You know, and some of them we skip, but it'll have everything that we're going to go through on the slides right there for you. Good. Okay. So the last thing is just in case you didn't see me on Halloween, there I am. So go take, what is it now? 11:10. Your next class, got a break. Your next class is 11:30. So go and we'll see you on Friday. Anybody voting? Anybody old enough to vote? Nobody old enough to vote yet, huh? All right. Well, you know, be careful anyways. Go. See you later.
Thank you.
Thank you. Thank you.